Okay, everyone, let's have a look at exercise for K-means clustering. Let's do practice the K-means clustering algorithms through this example. Suppose we measure two predictors. These predictors can also be called variables or features that are x1, x2 for 4 observations. So here we are using A, B, C, D to denote the observations. Now A 1, 1, and then we have B 2, 1, and C 4, 3, 4, 3, C, and D 5, 4. So this is X1, this is X2, predictor 1, predictor 2. Then you can plot them in the two-dimensional space. Previously, we used X1, this is the first observation, second observation, third observation, fourth observation. So these are the vector form to denote the observation. And on this end, this is the predictor. Okay. Now use the K-means clustering technique to divide the observation into two clusters. Suppose we use observation A and B as two initial centroid. Now compute the distance proxy matrix, use Euclidean distance. Okay. Now the algorithm, K-means algorithm, working this way: number of clusters, K initial clusters. Then you can randomize the centroid, and then distance every observation. Here we're using object, every observation to the centroid, and grouping them based on the minimal distance. And the no object move groups. If it is yes, then end. If no, then we if it is no object move, then no object. If there's no object move, then we end the algorithms. If there's still object move, we continue to update the centroid. Okay, let's try to work this out. Let's see. We have item A, B, C, D, right? Item A, B, C, D, and A is 1, 1, 2, 1, 4, 3, 5, 4. This is predictor 1, predictor 2. Now let's see the center 1. What is the center 1? The first center is actually, we are using A as the center. It's 1, 1. Okay, we're using 1 and 1. So this is the first center. What's the second center? Second center will be 2, 1, because we're going to use the B as the second center. Now let's calculate the distance from A to this one, to center 1. This is 0, right? And for this one is 1, because 1 minus 2 is 1. 1 minus 1 is 0, so it's 1. Because we are using Euclidean distance 1, even if you take the square, it's 1. Now this one is 1, 0, same. 4, 3. 4, 3, 4 minus 1 is 2. 2 square, 4 minus 1 is 3. 3 power 9. So 9 plus 2, 2 square. 9 plus 4 is 13. 13 square root is 3.61 and 2.83. And then 5 and 4.24. So we just calculate the distance between this one and the centroid, and distance from this one to the centroid. So we got this value. Now we need to assign them to the cluster, closest cluster. This one we should assign to the cluster 1, right? Because this is 0, cluster 2. And then this is cluster 2, because this smaller, cluster 2. Now we have these three BCD will become one cluster, okay? And then this A is a separate cluster. Now we're gonna update the centroid. Let's do it again. So we still have X1, X2, A, B, C, D, 1, 1, 2, 1, 4, 3, 5, 4. Centroid 1 is still 1, 1. And centroid 2, we need to average these three values. Average these 3, 2, 4, 5, add them together, divide by 3, 9, 2. So this will be 11, right? 9 to 11. The other one will be 8 over 3. This is a centroid 2. Now let's calculate the distance. This is 0. This is 3.14. This is 1. This 2.36. This is 3.61. This is 5. It doesn't change because the centroid doesn't change, but this change. 0.47, 1.89, right? So let's see the cluster number. So the first one, it should go to C1 because this is smaller. This one is also smaller, so this is also C1. And this is the second cluster is smaller, so C2. This is also C2. Now we change the cluster labeling. This 2 will be a cluster. This 2 will be cluster. Now we're going to update the centroid. Let's do it again. X1, X2, A, B, C, and D. So this is 1, 1, 2, 1, 4, 3, 5, 4. Now centroid 1 will be the average of these 2. So this will be 1.5 because this 1 plus 2, 3. 3 divided by 2, 1.5. These 2 add together divided by 2 is 1. How about C2? C2, these 2 together is 9. 9 divided by 2, and this 2 is 7. 7 divided by 2. Okay, now we are going to calculate this centroid 1, centroid 2. Now calculate distance between this every observation to the centroid. Now this one will be 0.5. Let me just give you the calculation. But in the real calculation, use the Euclidean distance. Calculate the distance between these two. 0.5, 4.3, 0.5, 3.54, and 3.2, 0.71, and then 4.61, 0.71. Now closest cluster. This is a C1. It's smaller than this one. This is smaller, right? And this one. This is smaller. This is smaller. So this is C1, C1, C2, C2. Now these two, CD will be a cluster. AB will be another cluster. Okay. So it doesn't change. The clustering labels doesn't change anymore. So group distance, no object move groups, then there's no object move anymore. So AB ended the algorithm. So this is our clustering results. That is AB is one cluster and CD is another cluster. It's like this. AB is a cluster. And the centroid is, the first one centroid is, let me see, 1.5. This is 1.5 and 1. So 1.5, this is 1.5. And then 1. So this first one, the centroid, the final centroid is here. These two stars are initial centroid. Now let me change the color. This is the final centroid. And the second centroid location is at 9/2. That's 4.5 and 3.5. So 4.5 is right here. 4.5 should be here, and 3.5 is right here. So the second centroid is right here. So the clustering results, they have two clusters. So this is basic algorithms of Kmeans clustering. So this ends this lecture.